Hi everybody, hope you are doing great. This is a WeeW tutorial and today you will learn how to control a 1602 LCD using an I2C communication. By the end of this tutorial, you will be able to set up the I2C communication with the LCD driver, and also you will be able to display messages. So if you would like to know how this is worked from scratch, just follow this tutorial. Before jumping to the video, let me take the moment and thank everyone for their support. I will keep doing my best to provide this quality content. So as usual, to support the channel, you can give us a thumbs up, make a comment or subscribe and stay tuned. So this is a part 3 of the series for the 1602 control tutorial, and we are going to use the I2C communication with the STM32F1 to control and display a 1602 LCD. So as usual, the code that we are going to write together is available on GitHub. The link is in the description below. The language that we are going to use is C. The program to code is Scale version 5. Finally, you may need to take a look in the previous tutorial where we are using 4-wire to control the LCD, as that will be extremely important within this tutorial. So for the hardware, we are going to use the STM32F1 based blue board, which is the aka blue pill, and a 1602 LCD display. Then finally we are adding an I2C 8-bit expander, which will be the PCF8574 board. So for the tutorial, first of all, we are going to take a look on the PCF8574 board review, a very quick one to understand how it works. Then we are going to understand the 1602 LCD connection with the STM and also with the board itself. After that, we are going to start coding, where we are going to establish the I2C communication with the PCF8574. Then we are going to update the function that we used for the control and data with the 1602. After that, we are going to update the initialization functions. Then finally, we are going to make some tests and display. So let's start with having a quick review on the board that we are going to add. So first of all, let's take a look that we do have at the far left jumper that is used to control the LCD backlight. You don't need to touch or change this jumper. This is our PCF8574 chip. No need to stop on this. And here we do have this jumper that can be soldered to change the address that we are going to use in the I2C communication. So the default board address is the hexadecimal 4E, and we are going to use this address in our tutorial. Finally, there is a potentiometer that is used to change and to control the contrast of the display. Okay, so let's jump now to the connection with the STM32F1 about using the I2C. So this is the connection. Sometimes the LCD and the PCF comes separately, so please solder them in this way. It's extremely important that you solder them in this direction. So the connection will be quite very easy, and in our tutorial we are going to use the I2C2 peripheral. So we are going to use SDA, the PB11 as SDA and PB10 as the clock communication. And after that, we have to take a look on this PCB board. So it's very cheap, like $0.5 US dollar, and then the address, as we said, is the hexadecimal 4E. After that, the LCD control mode, and we are going to see it here, will be the 4-bit control. So this is the circuit, how this is communicating, and you can see that P0, P1 and P2 are respectively the RS, RW and E connection with the board, where the from P4 to P7 are from D4 to D7 for the LCD. To understand much better how this communication works and how this communication is made, you will need to have a review in the previous tutorial to have a better idea how the 4 communication works. And finally, it's a 2.3 to 5.5 operation, so it can work either for Arduino or for the STM32F1. So now that we have finished this review, we can jump on setting the I2C communication for the PCF8574. So this is our initial screen, which is exactly the end of the previous tutorial about the 4-bit control for the LCD. However, I'm adding also the I2C driver, which I added the link for the tutorial in the description. and also the PCF8574 empty library, and that we are going to create right now. So we can jump directly and start setting up the code. First of all, we need to create a quick address reference. So we are going to put it PCF8574, and we are calling it address. And each time we need to specify which I2C we would like to select, and finally are we going to go for read or write. Okay, quite straightforward. And what we are going to use here will be the i2c. This is the function that we are going to add from the i2c library, the i2c drive. And here, so we are keeping the i2c, depends on the input, but the address here is the 0 for the hexadecimal 4e. And finally I need to put here the hexadecimal and a read write, because it will depend too. Okay, that's all. It's quite easy, simple. And finally what we need to add is just the some tx function for 1 byte. So it's just a 1 byte tx function, so tx byte. We don't need to really send any array, so it's just a void, quite a very simple one, PCF and 8574, and we call it tx byte just in case, so maybe another day we will need to add something. So as usual, char the i2c, and then we will need to put some data, so the data that we would like to send. Okay, so this is set, we can start. So we have i2c start function, which is a very simple one. So here still i2c, and after that we can add our PCF8574 address, and what we are going to need is the i2c, and here 0, because we would like to transmit and write in the slave chip. Finally, we are going to send some data, so i2c data here, and that will be quite simple again. So i2c, because we need to specify which i2c, and then data. Okay, so this is quite done. We just have to finish everything, but i2c stop, and putting here i2c. Quite simple and straightforward. And doing so, we just need to finalize all of this by copy paste in the header, which already have the i2c drive function. And here we are. So the i2c drive is ready, and we can jump to add for the next section. So we just completed the PCF i2c communication. We can now go carefully to the other side, where we are going to add the new LCD i2c command and i2c data functions using the PCF drive. So now that we do have the driver ready, we can jump and open both the 1602 drive and the header too. So let's add here and include the library we just created, so the PCF8574, I'm making it, so the drive, okay, .h. So this we're adding, by adding this one we can use, so I put PCF. Okay, that should be working now, and we can go and jump to our C file. So before jumping there, just to as a reminder for you guys, so from P0 to P7, which are the PCF pins, they are connected this way. So P0 will be connected to RS until P7 is connected to D7, which is this one, the LCD connections. And as a reminder, RS to RE are LCD command wire, and D4 to D7 are the LCD data wire. However, the P3 is connected to the screen light of the LCD, or the coming from the PCF, so this one must be always 1. P0 is the LSB, the lowest one, and P7 is the MSB. So we will see more later on in the details how this one will be set up. So, and here what we are going to do is taking the 4-wire transmit data function and adjust it based on the PCF. So let's open this one and go work on it. Okay, so what we can do, and very quickly and simply, just copy this, copy same as this function, and we are going to adjust it. That will be much faster for the other one because we will understand the logic, but for this one let's work on it. So first of all, for example, this pin out, this function that generate the pins as an output is not needed anymore, so we can just remove it. But after that we need to put the RS pin as high and the read write pin as low. So this will be equivalent to the PCF function, PCF, like I always put it wrong, PCF, yeah. So as usual we need to have a certain I2c to set up, but we would like to have this RS high and this one low, which means this one will be high, so 1, and this one 0, all the rest should be 0, this one 0, P3 should be 1 because it's always must be 1, and all the rest is 0, so it will be 1 0 0 1, and this is a 9, a hexadecimal 9, or even a normal 9 should be fine. So a 0 hexadecimal 0 9, and this one will be same. After that we need to put the LCD E high, so we would like to have E high and keeping this one same. So what we need to do is to have 1 0 1 1, and all the rest is 0. So what we can put here is a D hexadecimal, so it will be here. So we can just copy this one and putting this one as a 0D hexadecimal. Very simple, straightforward. So after that, here we do have a little bit of operation. We can not changing this one, so what we can do, let's put this one as a comment, and we can take this one. We need to keep this one same, so the hexadecimal D. So what we can do is taking all this data here, so this one should not be changed, and what we can do is putting this one like this. So we are just putting the data that we would like here, so we are going to put this one here, and then so this one is not needed at all, so we just need to have this operation. So make this one like this. So first of all we are going to take only this first part, or the second or the from bit 4 to bit 7 of the data, and we just put it with a D, which we need to keep it like that. So let's add 2 other parentheses just in case. Okay, and that's almost finished for the part 1, and after that we need to put the E low, and we have to be very careful. We need to keep this one here, we need to keep so only the E low, and we need to keep all the rest as same, so we need to get back to here for a 09. I hope that makes sense for you guys. If you do have further question, please let me know. I'd be happy to reply to them, so you just put it in the comment section. So we go back here again. So first of all, we should not forget to remove these ones. So we would like to have the LCD high again, so which is exactly the same function here, and we can comment this one. And after that we have a little bit of different functions, so let's start by commenting these 2 ones, and let's jump here to copy. We can copy this one, that's fine, but we need to change a little bit the logic that we put it here. So instead of putting this one, we are going to replace it by this one. Okay, and finally what we need to do is to go here and add this one here like this. Yeah, this is a correct one, but we need to change this one here to 9, so we do have the right picture on our code. So this one, actually we don't need, yeah, same, even 9 or 8 are same. There's no problem anymore because we already could read the function. So let's keep it 9 just for safety. that as we need to have this RS high for all the time, but 8 or 9 should be totally safe with no issue at all. Okay, so that's exactly how we set up the data function. We didn't really make a lot of code. We just adjusted some pin communication to the PCF. So this is exactly the same logic that we are going to use to create the command function. I guess you know what is the only difference between both commands. So it's a very simple, so let's call it also i2c here. And let's bring this code here. It's exactly the same exercise. The only difference is instead of having the RS high, in this one we put it low. There's a little bit of dry, but this is just to make things more clear for everyone. So as usual, so we don't need this pin output anymore. This is not needed, and we can just copy this one. But as you may also already knew, so this one should be 8, because both of them are here are low. So let's put this one like this and comment this one. So then we are going to use LCD. So it's not a D, but it will be equal to LCD just C. Yeah, after, so where is it? Let's go here. Yeah, and we put C here, and we don't forget to comment this one again. So let's bring this one again too, and so it's exactly the same code, so that's why we can do it quite quickly. And if you do again have any question, you let me know. So this is must be C, so we have to be careful about this one, and let's put this one here. Finally, we can copy this one and comment the LCDE, and putting here we go back to 8, which is what we need. So let's go back again. So we copy this one, as we need to have the E high, which is the bit number 3. So this one is C, and let's bring this function here, and let's put this one as a C, commenting these two ones so it doesn't mess up with our microcontroller pins. Finally, the last one here, where we can put exactly, not this one, sorry, no, we have to put this one. Okay, and here we do have 8. So with this one we created the command and the data functions, so they are operational, and we can jump to the big one, which is the init one. So before that, do we need, yeah, let's copy it just in case into the header, adding this new file. So this one to the header, and also this one to the header. We may need them or not here too. Okay, perfect. We just completed the very core function to control the LCD, so we can jump and make our init function. So exactly using the same logic, we are going to start updating the init function. So we are going to copy the init function we do have here. So it's a bit a very kind of a special one. There is not really too much logic on it, but this is something that we have seen together in the previous tutorial. This is extremely important, not for the I2C, but for the 4-wire communication. This was in the manual that we have reviewed, but it's extremely important to follow it. So this one, and so we need to add here, we don't need any other void here, but just the I2C. Okay, so first of all, we don't need any pinout, but we need here to add a very extremely important one, which is the i2c init function here, and where we put the i2c, and the communication can be using the fast mode. Okay, most of the devices now using it. So now we have to adjust all these ones. So for example, this LCD low and RW low. So what we can do, we can quickly copy from here exactly the same, and we are going to write slowly one by one on this one. So for this one, and after that LCD here high, so we need to have a C, and after that what we need to add here, so we need to add a 30. So let's do this one. So this is the manual how to switch for the how to say switch for the 4-wire mode, and this is extremely important to follow this. So this is not 3.8 but a 3C, which is extremely important. And finally what we put here, and we can put, instead of 3C will be a 3.8. Okay, so exactly same exercise again. Quite a very boring action, but extremely important to follow this one, so the LCD can switch to 4-wire mode with no issues. So let's put here same, and for this one again, so we can put this one here and add the C. I know it's a little bit boring but extremely important, so please bear in mind you have to follow this function, or you can use directly the code that is already in the GitHub. So again, same thing. So here let me copy this one and just putting this one again, and we are going to add this one here. So let's check. So everything looks to be working properly. We finish with the last one. So again, we are going to get rid of these LCD functions that we don't need, and after that exactly the same, so we can copy both, and I'm keeping them so for you guys to have kind of a reference and to be sure that there's no change in the code, and also it helps for some guidance. Okay, so we almost there, it will be very quick. So this one is correct, and what we need to add at the end is only this one. So let's add this, and we almost there. So now we finish this one. We need to add another extra one, but this is the switch to 4-bit mode. So let's quickly finish this one. So let's copy as usual this all here. So we have to say for 3 times that I would like to be in 8-bit mode, and then I can go to the 4-bit mode. So after that we have to go high. So let's take this one. So this one is getting high, and after that we are going to use, so this one will be a little bit different. It will not be a 3C, but it will be a 2, so this one will be a 2C, and let's comment all this here. Finally, we're just going copy this one, but we have to be careful and change the 3 to 2. Okay, so now we jump to this one, and we are needing to add the i2c here and putting for this one, so i2c, so it depends on the i2c communication. So here too, so we need, let's copy like this, so we can change like this, and we can update the command without really spending too much time. Okay, so we created our init function, really a very important one. If you have questions for the how this is working, you can go back to the 4-wire tutorial where this is well explained. Good, so this is ready. So let's, just in case, save and build to see if we do have the 7 warnings. Oh my god, so probably this is coming from all the space that for the old new line that I didn't add, this one and this one. So let's save again and check. Yeah, 0 error, 0 warning. The code seems to be good, so this part is quite fine. So we completed a very core important function, so we can say we almost finished, and we can now jump and start testing and having some displays to be sure that everything is going well. Before jumping to the main code and start to have some display on the LCD, I think there's some function that is better to adjust for the I2C and other to create. So let's start with the LCD. So let's put LCD I2C display. So this one here, so I2C. So it will be a very straightforward function to adjust. It will be based on exactly the same function where we are going to change the I2C only. So we are going to send. Where is the send? Yep. So we just take this code, yeah, and we are going to add here, instead of LCD data, it will be I2C data, and that's all. So this is the, and we need to add here I2C here. So it's always all. Yeah. So this one, and also let's go for, after that, the data one. This one, it's no, not the data. Let's check command message. Yeah, this is the one that we need to add to. So this is to add the line, so, and the position that we would like to have. And let's go here, so, and update it. So what we need to add also, so this one, and let's add a I2C. So here will be I2C, and the positions are here. So we need to make I2C for this one, and we add the I2C here. So you can see it's very straightforward, a little bit not dry, but very helpful later on when we are going to use our functions. And so these two functions are quite useful and helpful, and let's copy them to the header file. So let's go to the header and paste this one, and also add this one too. Okay, so we can add two other functions which will come with this previous one, which can be very useful. So let's use this one. So for this one, we are going just to use this one. So it will be a special type of this one. So we are going to use I2C, and the line will be 1, and the position will be, start position will be 0, and the array that we are going to add is just an empty space. 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16, and that's all. So that will be the function that we are going to create, just to have a blank on the line 1 and line 2. I think there's other ways smarter than this, but as a quick straightforward thing to do. So for this one, it will be line 2, but this one will be to make the whole thing blank, and that will be using both previous functions quickly. So this will be for this one I2C, and we just add another I2C here, so just in case, to make everything blank. Okay, I think that's all. So that's a quickly way. So let's add them quickly also to the here. So let's add this one again and again. So for this one, it will be 2, this one 1 2, and let's bring this one here. So we do have quite a lot of good function that we can use quickly without really having extra code in them, our main program. Okay, I think everything went well. We can jump back to our program. So before let's run, we do have one warning. So this is not ending with a line. Okay, so this is our main program. So here we need to change I2C, so I2C, and for this one also I2C, and finally as a message also I2C, and we need to add, so we are going to use I need to show you, which is important, the where is it, yeah, our circuit. So this is my STM32F1 connecting using the i2c peripheral. So we are using PB10 and PB11, and this is just connected straightforward with this device here. Okay, so right now when you just connect, you should see the light, and that should be fine. So let's go back again here, and there is some problem here, which is I should put 2, and this one also I should put i2c2, and in this one also i2c2. Okay, so let's look, not here, let's take a look on this one. Where is it? Here. Okay, so let's go a little bit smaller than this and try to save, build, and load. And we do have a welcome to the WeeW. So you can see it's really quickly and straightforward. Just one thing for you guys, you may not see nothing, and this is because the potentiometer that you do have here. So I will start turning it a little bit, and you will see it may disappear. So you may take a look and check what is going on there. So you have to a little bit play with this potentiometer here that we described in the function to check, maybe it just the display the contrast, which is not good. So that's all. Okay, so we could quickly and easily control our LCD display using the I2C communication, which saves a lot of wires. I hope you enjoyed this tutorial and wish you a very WeeW day.